All right. Good morning, good afternoon, or good evening, depending on your time zone, everyone. And thanks for joining us today. My name is Julian Krause, and I'm working as a customer success engineer for Vast Limits. That is the company behind the Uber Agent products. And in my role, I support customers, manage our partners, and do product webinars, just like today. Today's webinar is all about the new version Uber Agent 7.1 and what we've implemented in the new version. Before we start, I'd like to do a little bit of housekeeping. So the session will be recorded and the recording will be shared afterwards. Therefore, everyone in this meeting is muted. If you have any questions during this session, please feel free to send them to the chat box, where my colleagues Philip and Dominic, who also joined this call, are very happy to answer them. So first, I want to remind everyone of you that there are two Uber Agent products. Uber Agent basically provides endpoint visibility into your end-user computing and endpoint security. It's a digital employee experience monitoring and endpoint security analytics software that delivers exceptional insights into an IT landscape. On the left side, in the orange theme, you can see Uber Agent UXM, which is all about monitoring the quality of the environment. That means we're looking at all resources that could affect the user experience. It's also the foundation for our second and newest product, Uber Agent ESA. ESA stands for Endpoint Security Analytics and extends the use case to security for endpoints. By combining the functions of Uber Agent UXM and ESA, you'll get the total endpoint visibility by looking at the quality and the security of your environment. I've just mentioned that there are two Uber Agent products. The handy fact about these two products is that both are combined in a single agent. So we created one software that is capable of collecting metrics for the digital employee experience, application performance, and endpoint security. What makes it even better is that by combining these two products, we gain lots of synergy effects. You don't need to deploy multiple agents that consume resources on your endpoints. There's one agent that collects all necessary metrics, like the DEX-related topics, so logon duration, for example, and application performance or network communication metrics, but also the endpoint security analytics data set. Most of the performance and security analytics require monitoring of the same event as we see it. Think of the following scenario. A user calls in and complains that he's not able to work with a particular software anymore since he was moved to another office location. Of course, this could be a deployment or software issue, but also a security concern is possible. It could be the case that this particular application is handling sensitive information that is only available in a specific office location and not remotely, for example. What I want to say is that you need to focus on the big picture and to take all aspects into account. This is all possible by combining our two products. Another positive effect of combining two monitoring products into one agent is a huge efficiency gain due to our consolidated processing engine. Every event is enriched with important metadata that is collected by our other metrics. By doing so, we can keep the footprint on the machine's resources really small and maintain our agent to operate on a high performance level. This means roughly 30 megs of RAM and 0.5% CPU. So first, let's have a look at the changes we did in Uber Agent UXM, our digital employee experience monitoring product. User input delay. Uber Agent is now able to measure the user input delay, but first, let's cover what that actually is. The user input delay describes the time user input, for example, a key press, remains in the operating system queue before it's picked up by the user's application. Therefore, user input delay gauges overall system and application responsiveness. One has to understand that the user input delay does not include the time it takes the application to process the input. It also does not include the time for the input to reach the machine when we are talking about a remoting scenario. User input delay is the time that the information about some user input stays in the operating system's kernel input queue before it's picked up by the user's application. The user input delay is a strictly local metric, so it's independent of network or remoting protocols. Therefore, it's available for local as well as remoting sessions, including Microsoft RDP, Citrix HDX, and so on. A typical user input refers to mouse or keyboard input that could be all kind of input devices. So also microphones or headsets are possible. So why is user input delay an essential gauge for user experience? It's quite simple. Delays kill productivity. We've got the input delay metrics on a per process or per application level, but also on a per session level. Now let's have a look at how the session input delay looks like in one of our Splunk dashboards. So in the first panel, we can see the total values for all session inputs found in the time range selected above. So in this case, in the last 2 hours, we've seen an input delay of total 170 seconds. The maximum input delay or the average input delay is also available. How many input delay events were found during that time? In the chart below, we can see over time how the input delay has changed. So you can already see when something has happened in your infrastructure that could be mapped, for example, to changes in your infrastructure. Scrolling down gives you the information to see the, let's say, top or worst 10 input delays per host or per user. In this case, we're looking at a test environment, so there are just 2 hosts and 2 users in it. And if you want to find out what has happened for a particular user over time, you can click on a row in the data table by selecting just, for example, this session. And the charts underneath display the input delay over time, how it has changed for that particular user. Next up is our refreshed boot performance monitoring on Windows. Before version 7.1, we had our own technique to measure the durations for the boot phases until the user is able to work with the system. While the approach was technically correct, we thought it was good and necessary to be able to be compatible with a reference implementation in the Windows Assessment Toolkit. Therefore, we've completely updated our boot monitoring in version 7.1. Our approach is an independent solution that does not rely on specific operating system events that may or may not be written to the event log. We've got our own technique to avoid gaps in monitoring. Still, UberAgent metrics can be compared with the numbers from official Microsoft tools. However, Microsoft's tools are made to analyze individual boot performances. UberAgent has its strength there as UberAgent monitors your entire fleet of computers. Our new technique fully supports virtual desktops and works well with Windows Server as well as client operating systems. And while developing this feature, we discovered that Windows 11 handles the boot process quite differently. As a result, in some cases, you won't be able to get information about an active process during boot if there is no active session within the data collection period. But let's have a look at the boot duration dashboard here. So the dashboard itself is not new, but I think it's worth showing what we can pull out of a boot process. Again, the first row represents some overview values for all boots that were found in the time range selected above. So in this case, we're looking at today. So we've seen 3 boots on 2 different hosts. And on the time chart, you can see when those boots happened, and you can actually see how the main path and the post-boot duration was over time. If you scroll down a little bit, you can see those boots grouped by hardware model by default. Other groupings are available. If you want to find out which machines are part of a hardware model group, just click on the row and the new table reveals the actual information about the host and the boot times. Click on a row to analyze it in detail with our single boot dashboard. Again, some overview values for that specific boot. And underneath, we can see the I/O count per process on a top 15 view for all processes that were active during the boot. And scrolling down, we can see all those processes during the boot with their command line or with their full command line and their I/O metrics, for example. As some of you may know, we introduced the macOS version of UberAgent years after we released the Windows agent. Therefore, we are continuously working on offering UberAgent's rich set of metrics on macOS as well. The following new features are now also available on macOS. First off, custom script execution. You can use UberAgent to execute your own scripts and collect the output. The output is then available in the backend. So if you need information on your macOS system that is not part of the standard UberAgent metric set, you could collect this information with your own script executed by UberAgent. Next are our process statistic metrics. With UberAgent 7, we introduced the process statistics on Windows. UberAgent on macOS is now able to determine such metrics such as open file descriptor count, thread count, thread priority, and page faults too. If you want to find out which tabs your users are actually using, UberAgent now allows you to keep track of which tab the user is interacting with. All right, this is what I wanted to share for UberAgent UXM. Let's continue with the exciting updates we've got for UberAgent ESA. To get everyone on the same page, I'd like to start by addressing the question of what UberAgent ESA is. The idea is to gain visibility into everything related to endpoint security. We categorize this into the 3 following topics. Insecure configurations. Most of the attacks out there can be prevented by just enabling a good and secure configuration on your workloads. We deliver insights into the configuration of endpoints and applications that enables you to see which configuration is really applied or if your machines meet the security and compliance guidelines of your company. Overall, you could also see how exploitable your environment is. The next big topic is risky behavior. The idea is to identify risky or, let's say, unusual behavior on the endpoints, either by users or applications. Think of the following scenario. A particular application that is not supposed to contact any resource on the internet is connecting to an IP address outside your internal network. Then this is definitely something you should pay attention to. The third bullet point I want to mention is data exfiltration. Attackers often want to stay and remain undetected for obvious reasons. So if the attacker has already overcome the first hurdle, the intrusion, he would certainly like to steal data undetected as well. This could be done with a common technique called DNS exfiltration. Attackers could also easily steal data by simply plugging in a USB drive and copying data if they had physical access to your computers. But in most cases, they don't have and they don't need physical access because of the DNS exfiltration. Because attackers can easily use the network communication of your endpoints because the DNS protocol is often not monitored. It's also not possible to simply turn it off because otherwise nothing in your environment would work anymore. But we'll get to this topic in a few minutes in more detail. These are the key aspects of UberAgent ESA. Now you might say, okay, fine, sounds like just another EDR solution. Why replace an EDR with UberAgent? Well, first, I want to emphasize that we don't want to replace any EDR solution. We want to complement it. We want to raise transparency and visibility into an existing implementation. EDR solutions often do not provide insights into what they are monitoring, or if they do, it's very cryptic and very hard to read for humans. Our goal is to shed some light on insecure configurations, risky behavior, and data exfiltration. All this on a very detailed but easy to understand level. I'll show you how we detect risky events very soon with an example rule, and I'm pretty sure that you will agree that our rules are very easy to reach. Now that you have an idea of what the purpose of UberAgent ESA is and what our intentions were, let's have a look at what the components of ESA are. As you can see, the baseline is what we are collecting with UberAgent UXM. Many events are important to be considered not only when looking at digital employee experience monitoring, but also security analytics. And we collect way too many metrics to mention all of them here. So therefore, I want to highlight the following, which are quite easy to understand why they are important for security analytics. At first, process starts. We can see which process started, the parent process, the command line of the executable, and of course, when and from where it was started. Network communication and issues. We see from where to which target a connection was established and which data volume was sent or received. User logon is also interesting when looking at unusually long logon durations. We can see which processes were active during the logon. So think about an unwanted process that was slowing down the whole logon. UberAgent itself uses two key data sources. On the left side, we can see the security and compliance inventory, which covers the insecure configurations topic that I mentioned earlier. The security and compliance inventory, or SCI in short, is a script-based engine that runs various tests to detect the configuration status of a machine. On the right-hand side, we can see our threat detection engine, or TDE in short. By just looking at the name, I think it's pretty obvious what this feature is doing. It's constantly checking for events that match predefined rules. With the TDE, we want to identify the risky behavior. But there are more components in ESA. When we circle back to the three main topics I mentioned, we recognize the word DNS exfiltration. I'll cover that separately because I have a cool DNS exfiltration demo lined up for a little later in this presentation. We are also monitoring the root certificates, service creations, and scheduled tasks. The latter is also very interesting because many implement short-lived scheduled tasks to execute malware, for example. We start by looking at one of our key data sources in ESA, the security and compliance guide inventory. As I said, it's our script-based engine to detect insecure configurations. The engine executes the scripts periodically and sends the results to the backend. And we ship many predefined tests that are written in PowerShell to rate the configuration of your operating system or your apps, or even detect gaps when your configuration did not apply. But again, to represent the flexibility of our products, you are not limited to our tests. You can write your own tests to check compliance with your security policy or the configuration of your line of business applications. We support any scripting language, so you can choose whatever is best for you. Each test has a risk score as well as a test result score. The test result scores range from 0 to 10, whereas 10 is the best one can get, meaning a very low risk. But I'll get to that scoring technique in more detail in a few minutes. Because of our comprehensive list of predefined tests, I want to mention just a few, separated in categories. Let's cover 2 checks that can help prevent man-in-the-middle attacks. First up, operating system root certificate updates. This test verifies if the automatic root certificate updating is enabled and if the sync was not too long ago. List of additional root certificates. This test lists all additional root certificates that are not shipped with the operating system. Let's have a look at the checks we prepared to prevent PowerShell abuse. First off, is the old and insecure version of PowerShell, version 2, disabled? Are you using the constrained language mode in PowerShell, which reduces the possibilities a user has to abuse PowerShell? Next up, checks that can be categorized with lateral movement. So UberAgent verifies if you're using Microsoft's local administrator password solution to prevent your admins from using too easy passwords over and over again. Nowadays, Labs is already part of the operating system, but there are some settings that are worth to be checked regularly. Another check would be to verify if PowerShell remoting is enabled. The next category I want to mention is passwordless logon. So, for example, are your users using Windows Hello? And if they do, which authentication methods are they using? For example, PIN code or facial recognition. As mentioned earlier, these are just a few tests we implemented. Let's have a look at how the SCI looks in our Splunk dashboard. Therefore, I move to our Splunk app for UberAgent ESA, and we start by looking at the entry point, our security score dashboard. You may are familiar with the view because it's quite similar to our entry point of the UberAgent UXM app, the experience score overview. And the idea is to score your whole environment. So on the left, you can see an overall score for your whole environment with a trend indicator showing you if it's getting better or worse. In the middle, you can see how the score has changed over the past week. When we scroll down a little bit, we focus on the left-hand side, which is the security and compliance inventory part. Again, we can see an overall score and how it has changed over time. And each of these scores consists of category scores. So, for example, we've got scores for the category antivirus, for firewall, network, or PowerShell. And if you scroll down a little bit further, you can see how these tests scored over the day, and you can see how these test results are distributed to the whole environment. So in this case, we're looking at 7 tests that were executed with a very low score. If you want to find out what exactly happened in a particular test, just click on the test name, scroll a little bit further, and you can see the data table. So in this case, we're looking at the test protected root certificates and the category certificate. Underneath is a little description displaying what this check is all about. Again, we have this grouping technique here, and also again, you can choose different groupings. So now let's have a closer look at a particular hardware model. And then you can see all hosts that are part of this hardware model group. So in this case, there's only one host. If you want to find out what the actual result of this test was, just click on the host name. And you can see it is true, or the result is enabled equals true. So in this case, a normal user could install root certificates on this machine. Circling back to the 3 main topics of ESA, you remember the risky behavior bullet point. Therefore, we've invented our threat detection engine, or TDE, to detect the risky and suspicious behavior. The TDE is a rule-based engine that matches events with the rule definitions. Every rule is written in our own language, UAQL. That stands for UberAgent Query Language. Our language is very easy to read and understand, and it's quite similar to SQL. If the TDE finds an event that matches a rule, the event gets enriched with important metadata such as the effective process name, username, hostname, and so on. Every rule has a risk score configured. These scores range from 0 to 100, where 0 equals no risk and 100 is a very high risk. So by giving a risk score, you can classify the criticality of that rule. You may have heard about MITRE ATT&CK, the de facto industry standard framework to describe attack vectors. We're adding MITRE ATT&CK technique IDs to our TDE events so your team can see directly how an attack is described and how it can be mitigated. Every event that matches one of the rules will be visualized in our Splunk dashboards. You may have heard of Sigma, which is a security project living on GitHub. Sigma is a generic and open signature format that allows you to describe events in rule format. We pull daily updates from this leading open signature repository into our GitHub repository, where we convert them into TDE rules. Quite a lot of companies use Microsoft's tool Sysmon to monitor things or get information in case of a particular event. However, one has to understand that Sysmon is really just a tool. There's no support, so you're completely on your own, and you can't expect support from Microsoft. There are also no visualizations, and it's not very handy to write the rule definitions in XML format. But we've got you covered when you already have a Sysmon rule set. We provide a rule converter that can completely convert your rules to our own UberAgent query language. But of course, we are also shipping a comprehensive set of predefined rules. I want to mention just a few. Process starts from directories that are user writable. Usually, applications are installed in C program files where users can read but cannot write and therefore cannot harm the machine. If an app is being executed in a directory where the user can write, this could be a risk. The next rule aims to identify the kind of a dinosaur of the most common attacks, the macro execution in the Microsoft Office applications, such as Outlook and Excel. The TDE identifies suspicious network connections of applications that shouldn't be in touch with any internet resource. We can see if that app is in exchange quite regularly with any internet address. Another rule is matched when changes happen to the root certificates on an endpoint. There's also a rule that is triggered for service creations and deletions. Installing short-lived processes is a common attack vector as well. Finally, I want to show you what a TDE rule looks like. So at first, we've got this activity monitoring rule stanza. Then you configure a rule name as well as the event type to which this rule should be mapped. So in this case, we are looking to monitor process starts. Then you configure a tag for that rule. And the risk score I mentioned before. In the annotation field, you can configure the MITRE ATT&CK technique ID and then the actual query. In this case, we used a reusable expression here. So parent is Microsoft Office, consists of the Office processes like Word.exe, Excel.exe, and so on. So by configuring this reusable expression, you can simplify your rules. So in this case, we are looking at a process start where the parent process is Microsoft Office and the started process is in one of these, in this kind of array, like the started process is a cmd.exe, cscript.exe, wscript.exe, or ftp.exe, or the started process is a PowerShell. Let's cover another topic, the file system activity monitoring. UberAgent now has the ability to detect changes to objects in the file system. That can include file creation, changes, or deletions, but also create time changes or alternate data stream creation, among others. On Windows, we've implemented our own mini filter driver to monitor the file system while we subscribe to events from the endpoint security framework on macOS. Possible use cases could be to identify a download initiated by an application or to detect the destruction of forensic evidence. The latter would be, for example, the monitoring of a variety of logs that could be used to piece together a threat actor's course of action. We currently use the file system activity monitoring only in our TDE, but we may add other features that rely on this technique in the future. Therefore, let's have a look at how the TD events look like in Splunk. Again, we are on our security score dashboard, but this time we're focusing on the right side, the threat detection engine. Again, we can see an overall score, how it has changed over time, and which categories this score consists of. So image events, for example, image load, or network connection events, process starts, stops, our registry changes. And again, if you scroll down, you can see the tags that were found by the TDE with the amount of events, how many hosts are affected with the score. And you can also choose, for example, if you want to look at high risk tags or low risks, for example. In this case, the dashboard timed out. Sorry for that. Let's give it a few seconds to reload. So now we switched the view to low risk. And if you, for example, want to do an analysis on a particular rule, just click on it and Splunk will take you to our threat detection events dashboard, which is the specific dashboard for those TDE events. So when we click on it, the dashboard is filtered for the tag we clicked on, and then we can see how many hosts are affected, how many process names, how many parent process names, or for example, how many users are affected. We can see the applications that are involved with a percentage, events by tag or events by attack technique. In this case, it's just one result because the dashboard is filtered. Scrolling down shows you a graph over time so that you could, for example, identify risky behavior at a specific time. And by clicking on this row, the dashboard reveals more information what actually happened there. So, for example, when it's happened, on which host, again, the event type. In this case, we're looking at a net connect event. We can see to which IP address the host connected, the target name, the port, and the protocol. Or, for example, the user involved, if the process was elevated or even protected. And at the right side, we can see the MITRE ATT&CK technique ID. If you click on it, the dashboard displays a nice little description of what that actually was or why it was risky and how to detect and mitigate it. So we've covered 2 of the 3 main goals of ESA. Now let's have a look at the last one. How could someone exfiltrate the data from your well-protected infrastructure? For this purpose, we've prepared a little video where we are showing you an actual DNS exfiltration. So we start by looking at our DNS exfiltration and tunneling dashboard. If it's empty, it's good. That means that UberAgent did not detect any DNS exfiltration risk. What we are trying to do now is to exfiltrate 2 files from a corporate computer. Therefore, we've prepared a little PowerShell script that will read the files or read the bytes of the file and split them into chunks. Afterwards, these chunks are sent over the wire with a resolve DNS command to our fake DNS server. which is opened on the right-hand side. It's a Linux machine where we use this little script dnsteel, which basically acts as a DNS listener. So when we start the script on the left-hand side, we can see these chunks, and on the right-hand side, we can see what we received there. Just give it some time. And that's it. Now we close the DNS listener, and you can see we've received two files, the password.docx and password.txt. Now let's have a look at the txt file to see what we've got there. And here we have it, this typical super safe password that someone had on his desktop, for example. Now let's head back to the dashboard and reload it to see what UberAgent found out about this attack. There we can see UberAgent detected some DNS risk for the PowerShell process on that machine. And if you click on this bar, the dashboard takes you down to the data table showing you when it happened, which process was involved, on which host, and what the actual requests were. We can also see if there was a response, the response type, and why we classified this actual request as risky. In this case, because it was longer than 52 characters. There are also other options why we could classify a request as risky. For example, 27 unique characters, or no or empty responses, or for example, high entropy. Next up are some features and improvements I want to mention. And the first big feature I want to mention is our central config file management. Before UberAgent 7.1, you could configure UberAgent with local configuration files or via group policy. This means that customers had to use a deployment tool to distribute configuration changes, for example. Group policies were built to distribute individual settings, not sets of files. And especially when we thought of the fast-paced security world, we had to find a way to let customers distribute configuration changes fast and flexible. That's why we introduced the Central Config File Management, or CCFM in short. It's a technique where customers can share the configuration bundle on SMB shares. This has multiple advantages. The technology is established in enterprise IT, scalability and performance aspects are well understood, and there's an excellent interoperability with existing tools and processes. CCFM offers great configuration flexibility. Different types of machines may need different UberAgent configurations. With CCFM, endpoints can be pointed to the most appropriate configuration file share depending on location, department, or other properties. CCFM also supports configuration assignment by agent version. Furthermore, CCFM is built for scalability. Each endpoint keeps a local copy of the currently applied configuration archive. The agent does not depend on the CCFM file share for its regular operation. The file share is only accessed during configuration refresh checks. These checks occur at randomized intervals in order to evenly distribute the load on the file share. With great flexibility comes the need for great visibility. In other words, you need to know which agents use which configuration option. So for example, CCFM, local, or group policy. Then you need to know which version of a configuration is in use, on which endpoints, and from which CCFM file share agents are pulling the configuration. This information is now available in the backend as well. And before UberAgent 7.1, the administrator had to restart the agent service to apply the configuration changes. With version 7.1, UberAgent can detect meaningful changes and restart itself accordingly. The next topic I want to mention is our GitHub repo, where we store our configuration files. So just go to github.com/waslimits and you'll find all the version-related configurations there, and of course, our daily updated TDE rules I mentioned before. There are 3 more features that I'd like to mention. If you're using Windows on ARM64 machines, we can now use UberAgent 7.1 natively there as well. This means that every UberAgent binary has been compiled for ARM64 platform, including our kernel drivers. So there's no need for software emulation, and all UberAgent features are available there. We also released a new version of our help desk app that now includes the input delay metrics as well. This app gives your support engineers exactly the information they need for a typical first-level support scenario where browsing our detailed dashboards might be too much. Finally, I want to mention that our new event generator is in the last stages of development. So if you want to demo UberAgent or just browse through the dashboards filled with demo data, this app is right for you. We always do our best to test new releases on several machines in multiple environments. However, we identified one issue that led us to start working on a hotfix release, UberAgent 7.1.1. The issue occurs when ESA is enabled in the configuration, but only a valid UXM license file is applied. The agent would then turn off the ESA dataset and go into a restart loop. To avoid this, you could simply turn off ESA in your configuration by setting enable ESA equals false. Nonetheless, we highly recommend updating to the latest version as soon as we release the hotfix release. I assume that it will be available in the next week. Next up, as a little reminder, I want to mention how UberAgent is licensed. As UberAgent ESA uses a rich set of UberAgent UXM metrics, it cannot be licensed individually, but it's allowed to equip only a subset of machines with ESA. So in summary, UberAgent 7.1 brings a lot of cool and new features to the table. We learned about the all-new security score in UberAgent ESA, which allows you to assess the security posture of your environment. We also talked about how to distribute your configuration changes with a new central config file management with automatic agent restart. But there are too many changes in 7.1 to highlight all of them. For detailed lists, please see our changelog and release notes. So that's what I've prepared for today. I think we have a few minutes left to answer any questions, if you have any. Or if you have any questions later on, please feel free to contact us at info@uberagent.com. And for those of you leaving the meeting now, we'd like to thank you for taking the time today to learn more about UberAgent 7.1. Thank you. Just seen a question about evaluation licenses. They are available on our homepage in uberagent.com, and we have several license models that could be used for testing UberAgent ESA, for example.